So today we're going to talk about two different types of sequences. First, there's arithmetic sequences and then geometric sequences. Arithmetic sequences are numbers that use addition or subtraction to get the next term in the sequence. Whatever that value is, if it's positive or negative, whatever number we're adding or subtracting, this is called a common difference. And it's usually noted as the lowercase letter d. It can be modeled with a linear function. And actually that common difference would be the slope of the line. And then we're given the explicit formula for a arithmetic sequence. Next, we have geometric sequences. Geometric sequences use multiplication or division. And the division is always converted to a fraction. So for example, if we're dividing by 2 every time, that's the same as multiplying by 1/2. That value is called the common ratio, and it's noted as R in the explicit formula. This can be modeled using an exponential function, and we're given an explicit formula. Notice there's an exponent here to model a geometric sequence. All right, so let's write the explicit formula for this pattern. So the first thing that we need to do is we need to identify how many terms are in each, or how many numbers are in each image. So I have 5 squares in the first. In the next, I have 1, 2, 3, 4, 5, 6, 7, 8. And then in the last, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this shows that we're adding 3. So that means that I'm going to have an arithmetic sequence. So let's start to build our arithmetic sequence. So we're going to say a sub n, and I'm going to use function notation to represent this, just so I can do this quickly. So a sub n equals a sub 1 is my first term. So this is 5. Now I'm adding my common difference. I'm adding 3 each time. So that's my common difference. And then I'm multiplying that times n minus 1. N being my term number. All right, let's do one more. So we're going to identify now how many hexagons are in each figure. So the first one has 1 hexagon. The second one has 7 hexagons. And the last, let's see here, the center is 7, 8, 9, 10, 11, 12, 13. So here we're adding 6 each time as our rule. This means that we have another arithmetic sequence. So let's build the function. So we're going to start with a of n. And that's equal to the first term, which has a value of 1, plus our common difference. We're adding 6, so it's going to be a plus 6 times n minus 1. Let's take a look at another one. Okay, so now here the directions say to write the explicit formula, and we need to determine a term. Okay, so first we're going to identify how many squares are in each image. So the first one is 1, the next is 5, and the last is 5, plus 4 is 9. So my rule is to add 4. This means that, again, I have an arithmetic sequence. Let's write the explicit formula. So we're going to say a of n equals, the first term is 1, plus our common difference is 4, and then I'm multiplying that times n minus 1. So now I need to determine the value of term 10. So I could draw out these figures if I could recognize the pattern, and I could count up all the squares in that 10th term. However, that's a lot of work. So we're going to say a of 10. Notice I replaced the n with a 10. So we're going to do that on the right-hand side as well. So I have 1 plus 4, and then 10 minus 1. And you can use a calculator to simplify this, but this is 1 plus 4 times 9. 9 times 4 is 36, plus 1 is 37. So if I drew this out 10 terms, the 10th term would have 37 squares. All right. Now we're looking to write the explicit formula and then determine the value for term 12. So we start by identifying how many squares are in each image. First is 3, the next is 8, and the last is 1, 2, 3, 4, 5, 6. So that's 8, and 5 is 13. So it looks like we're adding 5 each time. So I have an arithmetic sequence again. Well, let's write the explicit formula. A of n equals, the first term is 3, plus the common difference is 5, n minus 1. Now we're finding the 12th term, so I'm going to change my n to a 12. 3 plus 5, 12 minus 1 on the inside of the parentheses, and then we can begin to simplify. So we have 3 plus 5 times 11. 5 times 11 is 55, plus 3 is 58. So if I continued this pattern and drew all 12 terms, my last term, term 12, would have 58 squares. Okay, so this sequence is arithmetic or geometric. Well, to figure this out, we need to determine the common difference or the common ratio. So here, let's see here, I'm adding 15. Here, am I adding 15 again? I am, and I'm adding 15 again. So that means that this is arithmetic. And that's because there is a common difference of 15. So what are the next 3 terms? Well, I would continue the pattern. I'm going to say 68 plus 15. Well, that's 83. '83 plus 15 is 98. And 98 plus 15 is 113. Now let's write the explicit formula. So I have A of n, or A sub n, equals, my first term is 23, plus my common difference is 15, and then I'm going to say n minus 1. Let's check this one out. All right, so we need to figure out if it's arithmetic or geometric. So from 90 to 30, that's minus 60, but the next one I don't do minus 60 again. So I can also say that this is division by 3. And that checks out here as well. And then 10 to 3.3 repeating, again, is division by 3. However, dividing by 3 is the same as multiplying by 1/3. So I'm going to say that the sequence is geometric because the common ratio is 1/3. So let's figure out the next 3 terms. 1.3 repeating. I'm going to convert 3.3 repeating. I'm going to actually write that as a fraction. So that's like saying 10 divided by 3 or 10 over 3. That's a fraction. That's fine. Okay. So now the next term is going to be 10 divided by 3, or 10 over 3 is a fraction, times 1/3. And if you recall our fraction rules, we multiply numerator times numerator and denominator times denominator. So 10 times 1 is 10, and then 3 times 3 is 9. We're going to repeat the process. So now we're going to multiply 10 over 9 times 1/3. Well, that's going to be 10 times 1 is 10, and 9 times 3 is 27. And again, 10 times 1 is 10, 27 times 3 is 81. So what's the explicit formula? So now we're going to say A of n equals, and we're going to write our starting term, which is 90, and we're going to multiply that times the common ratio, 1/3, and raise that to n minus 1. If I wanted to write this more formally, it would be A of n equals 90 times 1/3, and then n minus 1 up here. And if I had to type this into my graphing calculator, I want to make sure that I have parentheses around the 1, n minus 1. All right, I need to figure out my sequence if it's arithmetic or geometric. So here it looks like I'm subtracting 18. Am I doing that again? Yep, I am. Minus 18. And 29 minus 18 is 11. Okay, so now this is a sequence. This is a arithmetic sequence because there is a common difference of negative 18. I have to make sure I include that negative. So the next 3 terms, 11 minus 18, double check with your calculator, but that's minus 7. Negative 7 minus 18, again, check with your calculator, but that's minus 25. And negative 25 minus 18 is negative 43. What's the explicit formula? Well, this is going to be A of n equals my first term, 65. And now all my examples of arithmetic sequences before were addition. So now I have a negative common difference. So it's going to be negative 18. And I'm going to multiply that times n minus 1. You'll also notice that I can determine the common difference by taking one term, let's say 47, and minus 65. And that would give me my common difference. All right, let's do this one. I need to identify if it's a arithmetic or geometric sequence. So I could say, okay, well here I'm adding 9, but I'm definitely not adding 9 to 12 to get 48. So how could I figure out the common ratio here? So you might be able to do some mental math and say, oh, well, 3 times 4 is 12, 12 times 4 is 48, right? But if I wanted to calculate my common ratio, I could take one of my terms, let's say 48, and divide it by the previous term to that, which is 12. So clearly I have a geometric sequence because I'm multiplying by 4 each time. And that means that I have a common ratio of 4. So the common ratio is 4. So what are the next 3 terms? Well, grab your calculator. 192 times 4 is 768. 768 times 4 is 3,072. And 3,072 times 4 is 12,288. So what's the explicit formula? Well, A of n, or A sub n, equals, my first term is 3. I'm multiplying that times my common ratio, my bad up here. This should be a ratio, R, is equal to 4. And we're raising that to the n minus 1. That's my exponent. All right, thank you for joining me today. I hope you enjoyed learning about algebraic and geometric sequences.